this problem, problem 4, we're going to be simplifying square roots, and you are going to be working a lot with square roots as you work with the quadratic formula in this lesson. So I've included the square roots of perfect squares from problem 3 here, so you can start to get used to the values in these tables. So if you see square root of 9, that's going to be 3. These are all called perfect squares. Square root of 81 is 9, because 9 times 9 is 81. So you're going to use these numbers quite a bit. You should learn to recognize them. If you're asked to take a square root of a number that's not a perfect square, then it's either a prime number, in which case it cannot be simplified, or it's a composite number, in which case it might be able to be simplified. So let's take a look. So we have the square root of 50 here. 50 is composite, meaning it's not a prime number. So I have factors of 50 other than itself and 1, mainly 25 and 2. So I can rewrite the square root of 50 as the square root of 25 times the square root of 2. Well, the square root of 25 is one of our perfect squares here. That is 5 times the square root of 2, and that's as simple as we can make square root of 50. Square root of 18, well, 18 is 9 times 2, so the square root of 18 is the square root of 9 times the square root of 2. Square root of 9 is 3 times what's left, which is the square root of 2, so this is simplest form, 3 times the square root of 2 for the square root of 18. Square root of 24 is a lot of different products, 2 times 12, 3 times 8, but the one that's going to help us is 4 times 6, because in our products we are looking for the largest perfect square. So 4 is the largest perfect square factor of 24. Square root of 4 is 2 times the square root of 6, and even though square root of 6 is composite, 2 times 3, neither of those numbers is a perfect square, so we're not going to be able to break this down any further. Looking at part B, simplifying square roots of prime numbers, square root of 3 and square root of 47 are both prime, meaning there are no factors other than the number itself and 1. So we're going to say that these are already completely simplified. Part D, we're going to be simplifying square roots with fractions. So I'm going to use the information that I worked out in part A to simplify the process here a little bit. So square root of 50 over 2, we found that square root of 50 was 5 times the square root of 2 over 2. I cannot simplify between square root of 2 and 2. Those are completely different. So I'm done here. Square root of 18 over 6. Square root of 18 we found was 3 times the square root of 2. And 6 I know is 3 times 2. So the 3 is a common factor I can remove, leaving me with the square root of 2 over 2 as my final result. Square root of 24 over 4, I'm going to write the square root of 24 as 2 times the square root of 6. We found that up above. And 4, I'm going to write as 2 times 2. 2 is a common factor which I can remove, leaving me with the final simplified result of square root of 6 over 2. Parts E and F, we're going to simplify square roots with fractions that are a little bit more complicated. So again, I'm going to use information that was computed in part A. 2 plus the square root of 50 over 2 is 2 plus 5 times the square root of 2 over 2. Now, one thing you're going to have to be careful of is do not cancel these 2's. 2 is not a factor of the numerator. It has to be present in both terms. I have to be able to factor it out of the numerator in order to cancel it with the 2 that's in the bottom. 2 minus the square root of 18 over 6, that becomes 2 minus 3 times the square root of 2, we found that before, divided by 6. And again, you're going to have to resist the urge. It looks like there's all kinds of things that you could do with these numbers. You cannot do a thing. 2 is not a factor of the numerator. 3 is not a factor of the numerator. So there's no more simplification that can be done. For f, I have 8 plus the square root of 24 over 4. And I'm going to go up here a little bit because I need some room. 8 plus 2 times the square root of 6 over 4. Now, I do have a common factor. I have a common factor of 2. So 2 is common to 8 and 2 and 4. So I can rewrite that as 2 times 4 plus square root of 6 divided by 2 times 2. Be sure you understand this step right here. 2 times 4 is 8. 2 times the square root of 6 is 2 times the square root of 6. So all I did was to factor out a 2 in this step. I can distribute the 2 back through each term to verify I have the correct result. 2 is a factor of the numerator and of the denominator. I can write then a final simplified result of 4 plus the square root of 6 all over 2. And once again, do not cancel this 2 with this 4 because there are no more common factors in the numerator and denominator that can be removed. The last one in part F, negative 4 plus the square root of 16 over 12. That's negative 4 plus square root of 16 is a perfect square. It is 4 over 12 equals 0 over 12 equals 0.